this new topic is called image enhancement. Okay, image enhancement, and as the name says, as the name kind of clearly says, it means enhancement. In your own sort of interpretation, you would mean improve the appeal of an image, right? When you say improve, enhance an image, what you mean is improve the appeal of an image. Okay, and because of this word appeal, right, what happens is this has a connotation which is kind of subjective. Okay, because what you might find as very appealing, right, need not sound very appealing to the other person, or need not be very appealing for someone else. So in that sense, right, enhancement is not really is something that kind of borders on kind of being subjective, and hence, right, I mean, so as opposed to something else that we will see later, what's called image restoration, okay, which is entirely objective. Okay, so a task like this is entirely objective, whereas enhancement is more subjective by its very nature. To kind of give you an example of what I mean by this, right? Let us kind of look at something like a contrast of an image. Now, if you see an image, and somebody might say that, if you look at an image, somebody might say that, oh, right, it doesn't have a great deal of contrast. Somebody might say that, no, I'm not really happy with the contrast. Somebody might say, well, this contrast is actually enough. Right? Somebody might say, right, I mean, this is already very high, and therefore I don't need to do anything. So the point is, these things vary across let's say individuals. This is one example. Then another thing is, for example, illumination. Right, illumination again. When you when you look at the illumination of image, somebody might say that it is actually good. Somebody might say it is average illumination. What we mean by average illumination is that all parts are not kind of equally illuminated. Some people do not seem to be very easily affected by that. They would say, well, this illumination is fine. Somebody might say that no, right, this is not really that good because some portions are not really that well lit, or some portions are a little overlit. Again, right, so when somebody tries to do an illumination compensation, right, at the end of it, whether you end up increasing the appeal of the image or not remains subjective. Segmentation is one more example. Segmentation, where you say that you have an image, and then right, you would like to segment it into various regions. Okay, you could have some, say, n number of these regions. Okay, now should this image be segmented into n regions, or should it be segmented into m regions where n is not equal to m? Some people might say that two of these things probably look very similar to me, and therefore they ought to be merged. Somebody might say that no, right, they should be actually treated independently. Again, this is kind of a subjective matter, and therefore segmentation also, unless of course unless somebody comes and says that okay, just treat that there are n regions. But then that n itself, when somebody says that there are n, that itself could be, right, I mean, could be could be hard to buy. The sense that somebody might say, why is it n? Why is it not n minus 1? Why is it not n plus 1? Why is it not n plus 2? Can I break it up further, right, and so on. So therefore, segmentation also, right, can be kind of classified as somewhat kind of bordering on being subjective. Then there is another thing which is called reduction of noise. What is called noise reduction. Here again, in fact, right, I mean, I've seen that, I've seen in my interaction with these companies, for example, when there are some companies that actually deal with what is called the SEM image, what is called scanning electron microscopy image. Now, if you look at the SEM image, right, depending upon how you do the capturing, you can have images that are extremely noisy. You can have images that are really not so noisy. And apparently, right, there are some people that work with these images day in and day out, and they like it if there is some noise in it. If you show them a SEM image which is completely clean, right, they don't seem to think that it is natural, right? They have this feeling that what you're showing them is kind of unnatural, right? This is not the way a SEM image is, this is not a natural image at all, and therefore, right, when you do something like a reduction of noise, you have to be careful. So if somebody gives you a noisy SEM image, and if you think that you're going to completely smooth it out and show them a picture which is nicely filtered and doesn't have any noise, they may not actually like it. They'll say, no, this is very unnatural, right? This is not the way a SEM image ought to kind of look like. There should be some noise, right? Otherwise it appears very unnatural. So again, right? So what appeals to one person may not appeal to another person. Again, right? What level of noise is acceptable to one person may not be the same for the other person, and therefore, right? Such kinds of noise reduction, which come under the image enhancement sort of an umbrella, right? There is also something noise reduction that you can do in a very objective way that we will see later. But as long as you kind of think about noise reduction to increase visual appeal and so on, right? So in fact, when I say improve the appeal, I really mean here a visual appeal. Okay. Now the point is, right? So when you talk about improving a visual appeal, okay, it is not really obvious as to what should be done. I mean, to what level of noise reduction should one do? That would make, let's say, all of us happy. It's very hard. Okay, so that is why I call this. That is why, in fact, image enhancement by itself, right, as a kind of a technique, it comes under what I would say, a subjective. It has a subjective flavor. But right, that by itself, right, I mean, it does not mean that it is not mathematically grounded. Okay, it is all firmly grounded only, except that, right, there are some things, right, that I mean, you might have to fine tune. There are some hyperparameters at which you might have to choose appropriately, and so on. Okay, and at the end of the day, it remains open that whenever you enhance something, whether all of us will agree that what you've enhanced, whether you've really enhanced the visual appeal, or whether all of us agree that it has been enhanced to the same extent or not, right, is unclear. Some of you may like it. Some of you may say, well, maybe it needs a little more improvement. Some of you might say that maybe right, I would have liked the original image itself, and not the one for which you have attempted to increase the visual appeal. So it can have various flavors. Now, there's one more thing that I wanted to add to this, which is called a change detection, right? And what this means is that I mean, if I actually give you, if I have two images and suppose right, I subtract them, okay, and we are supposed to find out what is the change, right? This could be the same scene taken after some time. Okay, this is taken at time t1, this is taken at time t2, right? And we just subtract the image, take the absolute value after we subtract. Now you will find some intensities here, right? You might actually find intensities all over the place. Now, what should be treated as a true change versus what we think is kind of an artificial change? Again, right? Where do we put some kind of a threshold where we say that, right, if let's absolute value of I1, suppose I call this as I1 and suppose I call this as I2. If I1 of I comma j minus I2 of I comma j, assuming that that these images are actually perfectly aligned and so on, right? So greater than some kind of a threshold. Suppose I say that if this is greater than t, then I say that I compute a diff image, for which I will say that at I comma j, right, it has a value 1. Else I would say I diff I comma j is equal to 0. Now fixing this t, right, is not easy, because again, something that one person would agree is really a change, may not be agreed upon by someone else. So you say that, right, it is a change, whereas the other guy might say that, right, that's probably that t that you have chosen is too high, or they may say it's a kind of little too low, and so on. And this t is called really a threshold. It has a name. It's called actually a threshold, and how to choose a threshold is again tough. Now, in this context, I am going to show you a video, okay? But all this, right, it doesn't undermine the fact that image enhancement is a very important topic, right? None of this undermines that, okay? Which is also the reason why we actually teach image enhancement, and there are so many topics that come under it, which are all important. But the point is, right, even with all these uncertainties, right, that kind of surround us, in the sense that this kind of a subjectivity that surrounds this image enhancement, you can still do a lot. You can do a lot, right, by simply doing simple things. Now, this I'm going to show with one example. I want to illustrate this idea with one example. So what I wanted to so this vehicle, I wanted you to tell me, what is this big guy that's coming out?
Truck. Some water tanker.
Water tanker in Chennai. I mean, that is what you will see. Okay. Anyway, so the point is this, right? So there is so much information sitting out there, right? Just by doing a subtraction, we seem to be able to tell what is that vehicle. Okay. Now we went one further one step further, right? And then we actually did a classification based upon the activity matrix. Now, if you see this, right, can you see there's a bus going, and then behind every vehicle there will be a flash of color. Okay, that color indicates what it is. So green is a bus, blue guy is red is blue, and you will see how nicely our folks drive around. Okay, how nicely we follow all the traffic rules. And there is a red there. Okay, and then auto is yellow, red, right? So you can even classify. Okay, you can find out how many vehicles passed through that road, right, that time. Okay, using something simple as building an activity matrix, right, as you keep doing this image subtraction. Okay, so I just wanted to point out that this image enhancement, right, is actually a powerful thing. Okay, it may not be so fine. So I'll kind of close this. Okay. And therefore, right, I mean, as you saw, okay, even by doing a simple frame subtraction, you could actually find out what those vehicles are. You could classify vehicles, right? You're able to tell. If it is an auto, if it is a bus, if it is a two-wheeler, and so on, just by simply doing a frame subtraction. And of course, this is a very old idea that we did about 8-10 years ago with one of my students, and we could simply right do it by simply taking a camera. This was looking down, right, down the flyover, and then it was simply capturing the traffic sequence, right? I mean, as it moved under the camera. And then you would just do a differencing of the frames, and from this difference image you will build what is called an activity matrix. And then once you actually build the activity matrix, then from that activity matrix you can actually classify shapes, and it allows you to tell how many vehicles passed under the flyover at what time and so on, right? It gives you a count of the number of vehicles and all that, right? So you can see that something as simple as that, right, can do actually wonders. Now the point is, right, if you go further on, right, now one of the things, right, which we did, which is sort of implicitly assumed, was that, right, we could find a threshold T,